I've got an insider's story. I'm telling this only to you, my most electronegative audience members. Now, before we dive deeper, I've got a confession. There were a few compounds I desperately wanted to feature, but I couldn't unleash that kind of nomenclature chaos in the regular show. You know tin and lead, right? Not transition metals, not flashy, not the type to show up in a tuxedo with a d-orbital bouquet. But oh honey, they've got layers. They've been living a double life. Sometimes they're tin 2, sometimes tin 4.
Lead, same story.
Lead 2, lead 4. It's like they've got split oxidation personalities. And that's why we must use Roman numerals, not just for flair, darling, for truth, for clarity, for the heartbreak of mislabeling a compound and ending up with the wrong valence at the altar.
Next, elusive SbCl4-, the misunderstood BiO+, and even the flamboyant SnCl6-2-. But the studio said they were too niche, too unstable, or frankly, too dramatic for prime time. So they're still waiting backstage, sipping electrolyte cocktails and hoping for a cameo in Season 2. Next episode is dedicated to the ions that slipped past the red carpet. They're polyatomic, they're metal adjacent, and they refuse to be boxed in by the stock system. These are the backstage legends of the oxidation world. Let me level with you. There's a whole class of polyatomic cations, mostly nitrogen-based, that I wanted to feature. They're charming, stable, and show up in some very trendy compounds. But they didn't quite fit the drama we were curating. Methylammonium, found in methylammonium lead iodide, the darling of perovskite solar cells. Guandinonium, present in guandinonium nitrate. Hydrazinium, found in salts like N2H5Cl. Now this one almost made it, but it's overshadowed by its more reactive cousin, hydrazine. Hydrazinium is like the understudy who never gets stage time. Now, let's talk about the table of negative ions containing metals. You'd think these would be prime-time material, right? But these didn't make it to the regular show, either. Because the naming conventions are a minefield, a tangled mess of tradition and reform. Some get stock numbers, some don't. It's like trying to follow a plot where half the characters change names mid-season. MnO4-, permanganate. Cr2O7-2-, dichromate. These two are old-school royalty. They follow traditional naming, not the stock system. No Roman numerals here, just legacy names passed down like family heirlooms. Mn7+ and Cr6+ are understood, but never formally announced. Tetraoxyl vanadate 5, etc. This is the stock system loyalists. They wear their oxidation states like medals. 4, 5, even 6, because their chemistry demands clarity. The Roman numerals are there to remind you this isn't your grandfather's anion. Some get 8 without oxygen. Tetrachlorocuprate 2, hexachloroplatinate 4. These are curveballs. They're not oxoanions, no oxygen in sight, but they still get the 8 suffix and stock numbers. Why? Historical precedent in IUPAC's attempt to keep things consistent. But to the audience, it's confusing. Calling CuCl4-2- a cuprate is like calling a saltwater pool a lake. Technically not wrong, but definitely misleading. That's why these didn't make it to the regular show. Too much explaining, not enough drama.
And just like that, you're in on the secret.